All right, welcome back to Mr. PL's with Calculus. This is day number 8 of Unit 0, which is our prerequisites. And we're going to be doing piecewise functions in this lesson. And we're going to start off with a warm-up here where we're basically just using function notation, f of 0, and finding what the function is at that point. Now, remember, this is f of x is 0, so when you go to x is 0, you end up being a height of 2. So f of 0 is 2. F of 3 is also the same height, that is also 2. And f of negative 1 is also 2 because, in fact, that's all the exact same piece. Write the equations for each of the piecewise. I'm going to go ahead and skip that because that's literally what this video is all about. So let's take a look. The first thing you want to do when you're looking at a piecewise is understand basically what you're looking at. So you're looking at two separate pieces which may or may not be connected. It could be continuous or it might be some sort of discontinuity, meaning that it's not connected. Now, this is the equation and this is the domain of that equation, where this has a different equation for a different piece and this is its different domain for that piece. Now, the first thing you want to do is you want to find the boundary line. So in this case, it looks like when x is negative 2, that's right here. So I'm just going to split this. It's not a part of the function. That's just me splitting it into two sides to make it easier for me to graph it. Now, the easier part would be the right side, because when it says x is greater than or equal to negative 2, that means everything on the right side, because all of the domain that's greater than negative 2 is the right side of the graph. And when x is less than negative 2, that would be the domain that is on the left side of that boundary line. Now, it is also important to understand that only negative 2 is included in the bottom piece and not the first piece because that's the only one that's or equal to. They can't both be or equal to because then it wouldn't be a function, because then both pieces would, the same domain would have two different ranges, which is not allowed. Now, for this question, 3 is the answer. So from negative 2 on, 3 is the answer. 1, 2, 3, as you just saw me do in the warm-up. That is a constant piece going all the way across. It is always an answer of 3, no matter what the domain is, as long as the domain is greater than negative 2. Now, when the domain is on the left side, it's this equation, which is x plus 5. Now, there's a couple of ways of doing this, and the way that I would prefer is to go to the y-intercept like you would normally graph a linear function, and the slope is up 1, right 1, because its slope is 1. But remember, this is not on the piece because the piece only is on the left side of our boundary line. So I'm going to keep that. I'm going to keep going, keep going. Okay, so it looks like it starts in the exact same place and then just keep going that direction, and there's the other piece. Now, this is a continuous piecewise function because both of these pieces have the same endpoint. Now, I could do the same thing for the warm-up, and I won't do this each time, but I could solve for these. F of 3 is 3. F of negative 4, 1, 2, 3, 4 would be right. Okay, I didn't do this perfectly. So 1, 2, 3, 4 should be 1. That's if I put negative 4 in here. Negative 4 plus 5 is 1. That's the easier way of doing it. Or you can use the graph. F of negative 2, remember, is only in the second piece, so that's 3. All right, so in this question, it looks like 1 is our boundary line. So I'm going to put a boundary line right here. Everything on the right side is this equation, 2x plus 1. So here's our y-intercept, up to right 1. So it's included, up to right 1, up to right 1. The right side of the boundary is a linear piece. The left side of the boundary is quadratic, which means we know it's going to be a parabola shape. So what I could do is I could put 0, I could test it. I'm going to use a different strategy since it's not linear. It's not as easy. So I'm going to put in 1 into the equation, and it's not included. So 1 squared is 1, 1 plus 3. So once again, I'm making a table, and I'm going to use 1 and 0 and negative 1. These are all the integers on the left side of the boundary. 1 squared is 1 plus 3 is 4. So if I'm doing x squared plus 3. 0 squared is 0 plus 3 is 3. Negative 1 squared is 1. 1 plus 3 is 4. So 1, 1, 2, 3, 4. So it looks like it's going to be an open circle right here. Remember, the second piece does not include the boundary. and then it's going to be 0, 3, 1, 2, 3, and then back up to negative 1, 4. And that does make sense because this is a parabola type shape, as you can clearly see on the left-hand side. All right, so looking at one more of these. So once again, the boundary, in fact, you know what, since I'm only going to do one more, just to keep this a little bit short, so I'm going to look at example number 4, since there are 3 pieces to this. Now, one of them happens to be constant, so I'm going to find the 2 boundary lines. It looks like 0 is one boundary line, and 5, 1, 2, 3, 4, 5 is the other boundary line. Now, I'm going to start with this last one first. Everything greater than 5 has an answer of 3. So there's the answer of 3. I made it an open circle because it's not or equal to. So it's not included on the boundary, but everything to the right of it, meaning any domain greater than 5, will have that same height. Now, in between the 2 boundaries of 0 and 5, it goes by this equation. So it's not included at negative 1. Because on the left-hand boundary of 0, it's not included, but it will include the 5 the other boundary. So it goes up to right 1, up to right 1, up to right 1, and keeps going until we get to the boundary line. And then last but not least, we have the first piece, which is quadratic. So once again, since it's quadratic, it's a little more difficult, so I'm going to make a t-table. You don't have to do it this way. So x squared minus 1. So the boundary line is 0, and left of it would be negative 1, then negative 2, and so forth. 0 squared is 0, minus 1 is negative 1. Now it's 1, that makes 0. Negative 2 squared is 4, 4 minus 1 is 3. So I'll plot those points, and then hopefully I'll see the curvature of the graph. So once again, it's including this one, so 0, negative 1. All right, so I'm filling this in now because it happens to be at the exact same place as this piece. Negative 1, 0, and negative 2, 1, 2, 3. All right, so it looks like it is this side of the parabola. That looks like that. And there's your piecewise. So it looks like it's not a continuous graph because there is that jump discontinuity right here, but these first 2 pieces did connect to each other. All right, and I'm going to call it right there for this video. I know I didn't go over all the examples that we did in class, but it has a majority of them, so you can see, you know, ones with 2 pieces, ones with 3 pieces. The ones with 3 pieces obviously have 2 boundaries. So thanks again for watching, and have a wonderful day.